So we are going to be taking notes to start class today. And so if you would, go ahead and take a moment to get your notebooks out while the sub pauses this video to give you time to do that. Okay, hopefully you have your notebooks out now and are ready to go. If you need more time, ask the sub to pause the video for you. We're going to get going. So we're going to start our discussion today with two different graphs. And so if you would, at the top of your page, go ahead and throw down two graphs. And I'm going to ask that the sub pause this periodically to give you time to write. So now is probably a good time to pause and give them a chance to write these things down. Okay, coming back. What I have got on my first my first graph over here on the left, I'm going to put two lines. I'm going to put a blue line and I'm going to put a red line. I recognize that both of your lines will be the same color because you're probably writing with a pencil, and that will be fine. I'll just use blue and red for the purpose of our conversation. Now, these two lines look like they are parallel, but if you remember from our lesson on vocabulary, I have to put marks like that on them to show that they are parallel. And so now these two lines, the blue line and the red line, we can say for sure are parallel. And if you look at them, let's say that the blue line had the equation y equals 3 over 2x plus 6. We can see that the blue line is located higher than the red line, and so we're going to notice that that y-intercept right there is at 6, and that the slope of this line is 3 over 2. I'll pause here. I'll ask the sub to pause the video here and give you time to get this written down. Okay, continuing with this, and so remembering that we have a equation that is 3 over 2x plus 6 for our blue line, I'm going to create an equation for my red line as well. 3 over 2x plus 1. And so I will mark on the red line that that y-intercept right there is at 1, and that the slope of this line is 3 over 2. Again, I'll give you some time to write this down. Pause now if you need to do that. And once your scene looks exactly like mine here, we'll be ready to move on. So make sure yours looks like exactly like mine, and we'll be ready to further this conversation. What's going on here is that these two parallel lines, we need to recognize that there's something going on here. Their slopes are exactly the same. And so we can make a statement about parallel lines, that parallel lines always have exactly the same slope. And that would be true for any parallel line that we add to this. And I recognize you might need some time to write, so go ahead and take some time for that right now while we pause. Coming back, I'm going to summarize parallel lines really quickly. Parallel lines can have different y-intercepts because all that is happening is that line is traveling up and down the y-axis. And I'll demonstrate that now for you in the GeoGebra program. And so we're going to take those two lines that we had here and we're going to put them on GeoGebra. And so I've got y equals 3 over 2 x plus 6. And I've got y equals 3 over 2 x plus 1. Now you'll see again their slopes are the same and they are parallel. And an interesting thing about this is I could put any line on here that has a slope of 3 over 2. Y equals 3 over 2. X, oops, that x is in the denominator, that's not what I want. This is why Alex doesn't like it when you put the x in the denominator when you're talking about slope, because you would actually end up with those weird curvy green lines that I have over there, if that was the case. So we need to make sure that our x is out here to the right. So now I've got this green line that's also parallel. Let's do another one. Y equals 3 over 2 x plus 2. Another one that's parallel. Y equals 3 over 2 x plus 4. Another one that's parallel. I hope you're kind of getting the idea. Like I could put anything, any y-intercept after the 3 over 2. Let's do a negative one. Y equals 3 over 2 x minus 2. And every single time I'm going to end up with parallel lines because my slope is identical. The slope is exactly the same, and that is always going to produce parallel lines. Going back to my notes really quick, parallel lines will always have exactly the same slope. You can do whatever you want with their y-intercept, but the slope is the key to parallel lines. We're going to move over to the other graph now, and we're going to talk about a different set of lines. We'll keep the blue line, and I'm actually going to redo that one. I'm going to move it up a little bit so it looks more like the one on the left. It's terribly not straight. We're going to say that the blue line again has a slope of y equals 3 over 2 x plus 6. And don't go worry about writing this down now. We'll write it down after this next step. And so now this other line that's going to be intersecting the blue line is going to come this way. And this graph of the red line is going to have a slope of negative 2 over 3 x minus 4. And I will pause right now so you can get this graph written down, and make an effort when you create your graph. Make an effort to put these two lines perpendicular to each other so that they intersect at 90 degrees. We need 90 degrees right there in that corner. If it's not perfect, don't worry about it. Just get it kind of close. Go ahead, I will pause, and you can do that. Okay, coming back, we are going to look at both of the slopes for these two. And we need to kind of see if there's some kind of a relationship between the slopes of these two. I noticed that the first one is a 3 over 2, and the second one is a 2 over 3. So that is the reciprocal of each other. We flipped the fraction over. The key word there is the reciprocal. In 6th grade we often said flip it, but reciprocal is the word that we're going to use. The other thing to notice is that the blue line has a positive slope and that the red line has a negative slope. So perpendicular lines, one thing that we can take from this, perpendicular lines always have slopes that are the opposite reciprocal. I'm going to ask you to underline the words opposite reciprocal, because that's really the important thing to understand about slopes of perpendicular lines. I know it may take you a moment to write this down. Go ahead and get that done at this point. Okay, coming back, we're going to jump back over to GeoGebra. And I'm going to go ahead and leave those lines that I had already created there. And this time we're going to use the opposite reciprocal of this slope. So opposite means change the sign from positive to negative, and reciprocal means flip the fraction over. So opposite reciprocal, we're going to have y equals negative 2 over 3 x. Again, the x has to be out to the side. I'll show you what it does again. Look at, we get this weird kind of strange shape there if we do that. So y equals negative 2/3 x, and I can put any y-intercept on it that I want, again, like 4. Or I can move it down to 2. Or I can make it negative 3. Any one of these, no matter again where the y-intercept is going to land, is going to be perpendicular to all of those other lines, because the slope is a opposite reciprocal. Let's do another one. Y equals negative 2/3 x plus 1. That line is also perpendicular to those other lines. And it is parallel to the, so again, these two lines are going to be parallel with each other, and these two lines are going to be perpendicular with all of these lines. Again, the only thing we have to do to create a perpendicular line is to flip the fraction over, which is the reciprocal, and change the sign, which is opposite. So again, opposite, reciprocal will create perpendicular. For parallel lines, we want slopes that are exactly the same. So after taking the notes, the expectation is that there is an ALEKS assignment online for you that is called, let me see what it's called, Parallel and Perpendicular Lines Practice. I'm going to model for you how to do the different problem types that are on there. There are 9 different problems, but there are only 3 different problem types. And so I will do a couple of each. And I'm going to model what I expect in class. I do expect your notebook to be open next to your Chromebook. Because we do math on paper, we put answers on a computer. So please make sure that you do have a place to put your work down, always with you while you're working on a computer. So we're asked to consider the line, the slope, consider the line negative x plus 1. And so I'm going to say for this one, again, all we care about with this is the slope. The slope of this first one is negative 1 over 1x. Anytime we have a variable that's by itself, we can put 1 in front of it. I like to write my slope as a fraction. And so I don't know actually if ALEKS is going to count me wrong for putting negative 1 over 1. I think it will, because it does not like, I think it wants the slope to be a whole number when it's possible. I will try negative 1 over 1 and see what it does. So negative 1 over 1 would be the parallel line, because that would be, so the slope of the original is, and I'm going to use symbols, I'm not going to write the words parallel and perpendicular, that takes forever. So parallel, the slope would be the same, negative 1 over 1. Perpendicular, the slope would be the opposite reciprocal. So instead of negative, positive, and if I flip 1 over 1 over, I still get 1 over 1. So parallel would be negative 1 over 1. ALEKS is probably going to count that fraction wrong. Let's see what it does. Oh, it counted it correct. That's interesting, because on our last test it was making that wrong. Okay, we'll try another. The slope of the parallel line, so slope is going to be, so the slope on this one, we have another one. We got to be careful because the negative 1 is the first term that we run into here, but that's the y-intercept. So the slope of this one is actually 3. And I'm going to, negative 3, I'm sorry. And we're going to write it negative 3 over 1, just like, just because I like to put them as fractions, right? So a slope of parallel line will be exactly the same, negative 3 over 1. Slope of the perpendicular line will be the opposite reciprocal, so opposite of negative is positive, positive 1 over 3. And we'll do one more of this problem type and move on to the other 2 problem types. Here we have a slope of negative 4. So again, negative 4 over 1. And I don't think I even put my answers in that last one. That's okay. Negative 4 over 1, parallel would be exactly the same, negative 4 over 1. Perpendicular, opposite reciprocal. So instead of negative, it's going to be positive 1/3. So I'll go ahead and put those in this time. I spaced doing it last time. And I will try them both as fractions and see if ALEKS likes it. And that's not 1/3 Schlegel, that's 1/4. Typo. Let's check and see if ALEKS likes it. Yep. It does say you can simplify your answer, but dividing is not necessary. So it will still take the over 1, which is nice because that's the way I like to write my slopes. Let's move on to the second problem type. This one looks confusing, but it's not. So what I need you to do, actually I'm going to have to remove this problem type. So I'm going to skip this and move on to the next one. You will only have 6 questions on your thing. Okay, so this goes back to the idea that we had in the past about slope is a change in y over change in x. And so what we're going to do with each of these is we're going to use the fact that we know that the slope formula is y2 minus y1 over x2 minus x1, and we're going to find the slope of each of these lines. So coming to my always have a notebook here, it is impossible for me to do this math in my head. My expectation again is that you have your notebook right there. So for this first one, we have 2 points, 0, 1, and -5, -2. We're going to call this x1, y1, x2, y2. And we will do our deal to find the slope of that. I am not going to make you sit through watching me do that because it's tedious. I'm going to pause my video so that I can do the work and then come back with it completed. So coming back, you can see I have number 1, number 2, number 3, and I have found their respective slopes. And so if I take those slopes and just line them up, slope 1 is -3 over -5. I actually should have changed that to be +3/5. So this slope 1 is 3 over 5, slope 2 is -2 over 5, and slope 3 is -5 over 3. What we've got to do is look at those three slopes and see if any of them are exactly the same. And the answer is no. So none of these are parallel. And so what we also need to look at are there any opposite reciprocals? Opposite means if it's positive, you switch it to negative, or vice versa, negative to positive. And is there a reciprocal? And I do see a couple. I see 3/5 and -5/3 are opposite reciprocals of each other. That means line 1 and line 3 are perpendicular. So I'm going to go to line 1 and line 3 and say perpendicular. Then when I look at line 1 and line 2, there's nothing going on there. They are not the same, and they are not opposite reciprocals, so I'm going to say neither. Line 2 and 3, also they are not the same, and they are not opposite reciprocals, so I'm going to say neither. Fill in the box. Okay, whatever. So slope of line 1 is 3 over 5. I hope I did these right. We're going to see slope of line 2 is -2 over 5. Slope of line 3 is -5 over 3. Looks like I got it right. Let's try another. I'm going to do another one. Again, I'm going to do the work here while I'm on pause so that you don't have to watch me do that. Okay, so I've got my work done. And this should be a concept that's very familiar to you. We've done this a lot in terms of just how to find slope between 2 points. Recognize that it is going to be very important to simplify because 10 over 8 looks nothing like 5 over 4. So we want to make sure we simplify our slopes once we get them. And then I go through and look, okay, so I've got line 1 right here, line 2 right here, and line 3 right here. I look for any that are identical. Line 1 and 3 are the same, that means those lines are parallel. So 1 and 3 in this case are parallel. Then I look for any opposite reciprocals. Do I see any that are flipped over with the 4 on top and the 5 on bottom? The answer is no. And so, and the other piece that I have kind of a pet peeve about is I would rewrite this one actually as -5 over 4. Because we just moved that negative from the denominator to the numerator. Again, we do not like having negatives in the denominator. And now I notice something else. That one is also -5 over 4. So line 1, line 2, and line 3 are all parallel to each other. Line 1 and 2 are parallel. It did not look like it before I fixed that negative sign. So we're going to have to be very careful about simplifying our fractions and making sure that we move the negative to the numerator. Line 2 and line 3 are also parallel because their slopes are exactly the same. So for all three of these, I will put -5 over 4. And then check. Hi, boss. Let's see, I am correct, so that looks good. Okay, and so that's what our work is going to be around parallel and perpendicular. Again, on your homework, you will only have 6 questions because I just realized that these 3 are not going to be valid. So with that, go ahead and get started on this. If you finish this in class, you can go ahead and begin working on my path. Hope you have an awesome day.